So here's the beginning of our titration lab. Our objective is to determine the unknown concentration of a hydrochloric acid solution. So for this we will be using a burette funnel, an Erlenmeyer flask, a graduated cylinder, and an indicator solution. Our first step is going to be to rinse out the burette with water. Now, Liam is filling the burette with 50 milliliters of a standardized sodium hydroxide solution above the 50 milliliter mark, and then we're going to drain it down to the 50 milliliter mark to fill the tip. Here we have the burette as it is being drained into our Erlenmeyer flask, which needed to be filled with 10 milliliters of the unknown hydrochloric acid solution, and then you would add 2 drops of the indicator solution in order to actually see the reaction happening. Now you will slowly run the sodium hydroxide solution into the flask while swirling. When the solution starts to turn pink for a longer period of time, you need to slow the drops to a rate of about 1 drop at a time. You are finished when 1 drop causes the solution to turn pink and stay pink. You will then average those volumes together so that you can get a more accurate comparison and a more accurate data set. In our experiment, we ended up using 11 milliliters of HCl per trial. So in our first trial, we used 5.4 milliliters of sodium hydroxide. Our second trial was 6.5 milliliters. And our third trial was 5.3, which gives us an average of 5.73 milliliters of sodium hydroxide to complete the reaction. Now we have to do the formula to actually get the molarity of our hydrochloric acid solution. So first we need to convert our average milliliters of sodium hydroxide to liters, which would be 0.00573 liters of sodium hydroxide times the molarity of the sodium hydroxide, which would be 0.10 moles per 1 liter. Then we're going to times it by our molar ratio, which would be 1 mole of hydrochloric acid over 1 mole of sodium hydroxide. Now we are going to convert that to liters, or the liters of our HCl solution, which would be 1 over 0.011, which will give us our molarity of a 0.05212 molarity hydrochloric acid solution. Through all that, we can conclude that the molarity of the unknown hydrochloric acid solution is 0.05212.
We start the antacid lab with a mortar and pestle, a stirring rod, a burette, and 1 singular antacid tablet. We then ground up the antacid tablet in the mortar and pestle until it was left in a fine powder. Next, we turn the knob on the burette to slowly allow the HCl solution inside to drip onto the tablet. We continuously stir the mixture as more of the HCl solution drips into the vessel. The reaction is done when there is a noticeable lack of visual or auditory bubbling. We then disposed of the solution and cleaned the lab utensils. Afterward, we repeated the lab. The final step was to complete the lab analysis. We took the amount of liters used of HCl in both trials and found the milligrams of calcium. In trial 1, 0.01175 liters of HCl were used, and the milligrams of calcium was 471.2. In trial 2, 0.01065 liters of HCl were used, and the milligrams of calcium was 427.1. We then had to find what percentage of the FDA's recommended daily allowance, or RDA, of calcium was met. The average amount of milligrams of calcium between the trials was 449.2. We then multiplied 449.2 milligrams by 2 in order to account for dosage, which equaled 898.4 milligrams. With the RDA being 1,000 milligrams, we divided 898.4 milligrams by 1,000 milligrams, then multiplied by 100 to get the percent. It only came out to be 89.8% of the recommended daily allowance.